Hi, John here. In this video, we're going to look at an engine cooling water system. And I'm going to explain to you how we regulate the engine cooling water system temperature in order to prevent the engine overheating. So as you can see here, we've got a 3D animation. What we're actually looking at is a 4-cylinder inline internal combustion engine. We've got 4 pistons, 1, 2, 3, 4, and they're in line. We've got a crankshaft, and the crankshaft connects to an axle fan. It's this item here. Notice the fan is actually driven by the crankshaft itself. We've also got a jacket water pump. That is this item. A thermostat. This item here. And then we have a radiator. This is effectively a heat exchanger. An expansion tank. And all the associated hoses and piping. So what we'll do, we'll dive straight in and I'll walk you through what happens when an engine starts, and we'll look at the components as we go along. So let's play the animation briefly. Okay, we can see our animation here. We see the engine is cold. These blue arrows indicate that the cooling water system is cold. If we get red arrows, it indicates that the cooling water system is becoming hot or is hot. We can see that the arrows are flowing around the combustion space or around the cylinders. That's why we call it a jacket water system. A jacket water cooling system and a cooling water system are the same thing, so don't get thrown off by the wording. Jacket just means literally that the cylinders are wearing a jacket, and that is to keep them at an optimum temperature. What I'll do, I'll pause the animation, I'll zoom in, and I can show you what's happening. We have a cooling water pump. It's this pump here. It's sucking from the jackets of the engine, and then we're going to send our cooling water to a thermostat. Now notice that the engine is cold, so the thermostat is actually going to send the cooling water down this way. I'll see if I can get an arrow. There we go. The flow is coming along and down here. We'll look at the thermostat in more detail later, so don't worry too much about that now. But the cooling water is coming down and it is bypassing the heat exchanger or the radiator. It's coming along here and it bypasses our radiator and it is recirculating. The reason it's recirculating is because we're not always trying to cool the engine. We want to regulate the temperature of the engine. That's the idea behind a cooling water system. We want to maintain the optimum operating temperature. And this is going to be around 80 degrees Celsius. So that's what's happening when the engine is cold. So we've started the engine, it's cold at the moment, but as it continues to operate, it's going to generate more and more heat. And at some point, we're going to see those red arrows coming through. And there we go. We can see now the red arrows are coming through, so the engine is hot. But notice straight away that the red arrows are being diverted to the radiator. So let's zoom in on that. We can see now that the thermostat has changed position. The lower piece, or the lower pipe, is now blocked. The thermostat has blocked that piece off. However, the top part of the thermostat is now open. You can see there's a gap in the top, and that is allowing the flow through the top of the thermostat. The flow then is going to the radiator, and we're cooling that cooling water down because this fan is driven from the engine. It is blowing the air across the radiator. The air is symbolized by the white arrows, and we blow the air across the radiator, cool the cooling water down, and we can see at the bottom here we've got blue arrows again, so we've cooled the cooling water down slightly. Other than that, the system is the same. So rather than using this pipe here, we're sending the flow the other way and we're cooling the cooling water down. The thermostat, though, is a proportional device. It will open and close a relative amount based upon the engine temperature. So if the engine is running very, very hot, the thermostat will be fully open. So you can see there the thermostat expanded slightly because the engine temperature increased, and now the flow is going the other way. Let's back that up again, see if we can get that. And then again. So there we go, cold engine, slowly becoming hotter. Now it is hot and the flow is going to go the opposite direction. This position though of the thermostat as it is now, I'll see if I can get it somewhere in between. Okay, as it is now, we've got the same effect. We've got the bypass closed off, but it's important to realise that the thermostat regulates. It's going to be opening and closing, moving up and down based upon the temperature of the engine. So sometimes it might not be fully open or fully closed, or fully bypassed I should say. Sometimes it might be somewhere in between. And that's because the engine sometimes is not creating the maximum amount of heat. Maybe it's just idling. And in that case, you might want to send some cooling water to the radiator and some through the bypass. That's why they call it a thermostat, because you're regulating the thermal temperature. This is also a feedback loop because the temperature of the engine is controlled by the thermostat, and then the cooling water tells the thermostat what the engine temperature is, and then the thermostat regulates the temperature again by deciding the flow direction of the cooling water. Let's have a look now at a thermostat in more detail. Okay, so here we are looking at our thermostat. Give it a little spin so you can have a look at it. You can see on the top here we've got a rod sticking out. This rod here. This whole section on the top, the brass looking or copper looking piece, is the primary valve. Around the primary valve we have a black piece, which is a piece of rubber like material used for sealing. The next black piece we have around here is also used for sealing. You actually push this down into a recess within the engine and it sits in there quite comfortably, and then you'll put the cover on, so it makes it quite easy to change the thermostat. You can also see there's an air bleed, and if we go down you can see a spring, another spring. This section here is known as the secondary valve or the bypass valve, and perhaps the most important item is the charge cylinder, which is this whole orange space around here. So how does it work? We already know that if the temperature increases, then the top primary valve will open and the bypass valve will close, so we're not bypassing the radiator anymore. And if the temperature decreases, then the bypass opens and the primary valve to the radiator closes. So that's what it's doing, but how is it doing it? As you can see, it's quite a simple design. Well, the way it's working is that there is wax within the charge cylinder here, and the wax is in a solid state below about 80 degrees Celsius. When the wax becomes hot, it turns to liquid, and when it turns to liquid, it requires more volumetric space, or is of a larger volume, and that larger volume will push a rod out of the charge cylinder, and it will actually close our secondary valve or our bypass valve. So this rod here, from there to there, it actually goes up into the charge cylinder. When the charge cylinder becomes hot, the wax melts, becomes liquid, its volume expands, it pushes the rod downwards, and that then closes our bypass valve. So this secondary valve here is pushed down onto the seat and the radiator bypass is closed. So that's what's happening when it's too hot, but at the same time the primary valve, this one here, will be opened. And that means the cooling water is then going to our radiator. When the cooling water becomes cold again, the rod here will retract because the wax within the charge cylinder has a smaller volume and requires less space. So the rod retracts upwards, the bypass valve opens, and that means we are not sending cooling water to the radiator. So as you can see, we are proportionally regulating the response of the thermostat in accordance with the engine cooling water temperature. I'll click here, I should be able to see the annotations. Okay, and there we go. So there's some annotations here. Engine thermostat, what it does, the air bleed, main valve, primary valve, etc. Secondary valve, also called bypass valve. So you can see all these parts labeled. This is available on the website, so I encourage you to go there and check out this 3D model. The cooling water system is also available on the website, so go and check it out and cement what you have learned. Let's go back to the cooling water system model now for the rest of the video. So hopefully now you understand how the cooling water system works. I just want to do a quick note here on thermal expansion and thermal contraction. Thermal expansion is catered for by a header tank. That's this tank here. As the cooling water system gets hot, some of it may expand if the temperature becomes very hot, and the cooling water will go into this pipe and will store the cooling water in a header tank. So the cooling water header tank allows for thermal expansion of the system. If we don't have this tank, then what's actually going to happen is the cooling water will expand. It will pass through a valve here, come out and just leak down the radiator or through the pipe and then leak down. So we have the header tank there so we can store the cooling water in the top, and this allows for thermal expansion. The opposite of a very hot engine is a very cold engine, and we also have to take precautions against this as well. In order to protect the engine from freezing, we will add antifreeze into the cooling water system. The antifreeze prevents the water from freezing at, for example, -5 degrees Celsius, and it's very, very important that we do have the antifreeze in the engine. If we don't have the antifreeze in the engine, what will happen is the cooling water will freeze at -5 degrees, it will expand, and we will rupture or crack our engine, as well as potentially damage other engine components. So it's very important that the cooling water is not allowed to freeze and expand. In addition to having antifreeze in the engine, we're also going to have a corrosion inhibitor, and this will help prevent rust accumulating within the engine cooling water system areas, such as the jacketed cylinder liner, the pump, the thermostat, and all these corrosion inhibitors stop rust accumulating there, which ultimately may foul our heat exchanger and reduce the efficiency of the cooling water system. If you liked this video,